All right, this is part 3 of our basic chemistry lecture. So water molecules may also dissociate or form ions. If we look at this simple reaction, a water molecule may dissociate to form a hydrogen ion and a hydroxide ion. Notice that the hydrogen ion has a positive charge while the hydroxide ion has a negative charge. I sometimes call hydrogen ions protons, and that's simply because if a hydrogen atom loses an electron to become a hydrogen ion, then it's simply a proton that remains. Our hydroxide ion is this oxygen atom with one hydrogen here, and because it's gained that electron, it has a negative charge. So the ions and their concentrations of these hydrogen ions affect something called pH. Now the pH scale goes from 0 to 14. 7 is right in the center. Substances with a pH of 7 have an equal number of hydrogen ions and hydroxide ions. So in distilled water or deionized water or pure water, the number of hydrogen ions and hydroxide ions is equal, and it has a pH of 7. As solutions show more hydrogen ions, in other words, the concentration of hydrogen ions is greater than the concentration of hydroxide ions, the solution is said to become acidic. And on the pH scale, these are substances that have a pH lower than 7. While on the contrary, substances in solution with a higher concentration of hydroxide ions are said to be basic. And so the pH scale from 7 to 14 includes basic things, or sometimes known as alkaline things. Now, if we look at some common examples of solutions and where they fall on the pH scale, again, here's our neutral mark at 7. Notice things like colas and vinegar, they are fairly acidic with a pH of 3, while stomach acid has a pH of 2. And it's important to note that this scale is a logarithmic scale. So as we increase or decrease one order of magnitude, the alkalinity or the acidity really increases. So seawater has a pH of around 8. It's slightly basic, while things like household bleach have a pH of about 12.5 and are really basic. So again, to kind of reflect on this pH scale, neutral is 7. As we go from 7 to 0, acid strength increases. As we go from 7 to 14, the strength of the base increases. So for example, your stomach has a pH of about 2, and your stomach's acidity is their part to help with digestion, especially of large proteins. Now, your stomach is lined with mucus and very thick epithelial skin tissue so that the acid doesn't destroy it. But what about the material after it passes out of your stomach and into your small intestine, where the nutrients need to begin to be prepared to be absorbed? Well, what happens is your body adds something called a buffer. Buffers are added to solutions to help minimize the changes between hydrogen and hydroxide ions. So by adding an alkaline buffer to the material that comes out of your stomach and into your small intestine, we can raise the pH slightly. And that's exactly what happens. You also see the same thing occurring when you add a buffer to your stomach by taking an Alka-Seltzer, maybe after eating a very spicy meal.